Hello everyone, my name is Javier Obeso. I'm a TA1, and this week we're discussing about meta-analysis and subgroup analysis. And I wanted to discuss about an important part of analysis, which is publication bias. One of the major threats to the validity of meta-analysis. So throughout this presentation, we will discuss what it is and what are the ways to detect its presence in our study. So first, what is publication bias, right? So it's a publication or non-publication of research findings depending on the nature and direction of the results. This is also referred as a file drawer problem, which means that the nature of the bias is that studies which fail to reject the null hypothesis are less likely to be published than those that produce significant results. And we all know that journals are more likely to accept the manuscript that shows an effect than a study that was unsuccessful and was not able to reject the null hypothesis. Additionally, in some industry sponsored trials, the sponsor retains the publication rights and they're usually not very sympathetic towards publishing negative results. And why is this important? Well, omitting unpublished studies to review could yield a bias estimate of an intervention effect, creating a fake beneficial treatment effect, and we can miss important adverse effects. So assessing this it's a critical step for our meta-analysis. So the next question is, how can we assess this, right? There are many ways, but today we will discuss the two main tools to assess publication bias. The first one will be funnel plot. So funnel plot, it's a graphical representation of our data in which the effect estimates are present in the x-axis and indirect measurements of the study size, which such as standard error, is represented in the y-axis, and studies will be represented as dots. So basically, it's a plot of the variability of the individual studies against the mean effect size. And as we know, the larger the sample size, the lower the variability of a study. Thus, the smaller studies scatter wildly at the bottom, and as the sample size increases, they spread narrower at the top of the pyramid. So the final plot assumes that we will have a symmetrical distribution with many studies above and as there are as above the mean as there are below the mean. So just to recap, the x-axis represent the effect size estimate of individual studies, and they should be present on both sides with results in favor and against the pooled effect estimate. However, if we found an asymmetrical distribution in the pyramid, this will suggest publication bias, with usually more results showing a positive effect. And the other test we have, it's our backup test is eager test. This basically tests the symmetry and it's a linear regression of the standardized effect against the reciprocal of the standard error of each estimate. So the null hypothesis of the Eagers test is that symmetry exists in the plot. So p-value less than 0.05 indicates publication bias when we use this test. So just to finish, how can we avoid publication bias in our meta-analysis? Well, we cannot avoid it. We don't have control of what's published out there. However, in order to minimize potential publication bias, efforts to include the maximum number of studies should be made. Even the ones that were not published, we can achieve this by searching in the great literature and studied registries. And this is why in recent years there has been an effort to have all clinical trials included in a registry prior to enrollment of participants. So just to finish, um, how can we improve our search? Where remember to use your word strategy, and at least two databases to search for the references list and bibliographies of included studies, search in study registries, consult and include experts in the field, and search for great literature. And that's all. Thank you.